Unit 5, Learning Target Number 9. Use ratio and rate reasoning to solve real-world problems. Over the course of these lessons, we've already talked about how to solve problems with ratios using things like graphs and charts. But one of the things we haven't talked about yet is called a tape diagram. And a tape diagram can be kind of useful when we want to solve ratio problems. So let's take a look at an example. There are 84 students at Camp Fun. We'll put an exclamation mark there. Camp Fun! Or something. Anyway, the directors divide the students into 4 equal teams. Red team, blue team, green team, and yellow team to play Frisbee football. Teams blue and red play each other first. How many people are on the field? So we can use a tape diagram to kind of visualize what this looks like to break this down into these 4 teams and how many people are going to be on each team, etc. So let's use this tape diagram. A tape diagram is really just a little bar. That's all there is to it. And then we divide that bar up into equal pieces. So we'll divide this up into 2 equal pieces, and then we'll divide each of those equal pieces into 2 more, and that will give us 4 equal pieces to our tape diagram here. Now, we know that there are 84 students. There are 84 students total at Camp Fun. And we know that the directors divided them up into 4 equal teams. Not just 4 teams, but 4 equal teams. So what we need to do is to find out how many people are in each one of these teams, because this might be the red team, and this might be the blue team, and this might be the green team, and this might be the yellow team. So let's try that. Let's try dividing these up. So we'll start with 84 divided by 4, and I'll just do it over here on the side. 4 goes into 8 2 times. 2 times 4 is 8. We subtract that, we get 0. We bring down our 4. 4 goes into 4 one time. 1 times 4 is 4. We subtract those, and we get 0. So 84 divided by 4 is going to be 21. That means that each one of these teams is going to have 21 members on it. 21 members, just like that. 21, 21, and 21, and 21. So then we find out that teams blue and red play each other first. Blue and red. So we know that all of the teams are the same size, but let's just go ahead and look at blue and red since we took the time to label them. Here's blue and here's red. How many people are on the field when they play their game? Well, that's pretty easy. The blue team has 21 and red team has 21. We add those together and we get 42. So there'll be 42 people on the field. And that's all we do to use tape diagrams. They're just little boxes that we divide into pieces, and we use them to solve some basic problems. Now let's try to put all of this together. We've talked about ratios, and we've talked about rates and unit rates and percents. We've talked about all those things, so let's try to put all that together to solve a few problems. Here we go. A class with 25 boys and 25 girls, so 25 boys and 25 girls, were asked whether they preferred cars or trucks. So cars or trucks. The chart shows the results. Here we have it. Boys, 13 boys preferred cars, 12 boys preferred trucks. That equals to 25. Girls, 21 girls preferred cars, and 4 boys preferred trucks. So we have a total of 50 students, right? We add those together. 25 boys and 25 girls. We add those together, and that gives us a total of 50. So let's begin with the first problem here. What is the ratio of boys who like cars to girls who like cars? So our ratio should have boys who like cars on the top and girls who like cars on the bottom. Boys who like cars, there were 13 of them. And girls who like and prefer cars, they had 21 of those. So our answer is 13 over 21. 13 to 21 is our ratio. Number 2, what is the ratio of, we got to underline our word here, ratio of girls who like trucks to all the students surveyed. All the students surveyed. So let's first take the girls who like trucks. Girls who like trucks. It looks like there were 4 of them in this survey. 4 girls liked trucks. Now, all of the students surveyed. Well, how many students were surveyed? We had 25 boys and 25 girls. which again gave us a total number of students of 50. So we wind up with 4 over 50. That's our ratio. However, we have to pay very close attention, just like we do on K-Prep, to all of the instructions. It says to simplify if needed. So we'll put 4 over 50 here, and we'll begin to simplify. Now 4 and 50 have a common factor, that is the number 2. So 4 divided by 2 is 2, and 50 divided by 2 is 25. Do 2 and 25 have a common factor? No, they don't. So we are as simplified as we're going to get. So our answer is 2 over 25, and we'll circle this answer too, because we always want to circle our answers. Number 3, express the ratio of boys who like trucks. So our ratio of boys who like trucks to girls who like trucks as a unit rate. Now hopefully remember what a unit rate is. It is a ratio that has 1 in the numerator or in the denominator, a ratio or a rate that has 1 in the numerator or the denominator. So let's first find out our ratio of boys who like trucks to girls who like trucks. 12 boys preferred trucks, 12 boys preferred trucks, and 4 girls preferred trucks. That's our ratio of boys to girls who like trucks. Now we want to express this as a unit rate. That means we want one of these to be a 1, either a 1 in the numerator or a 1 in the denominator. How do we do that? Well, we could simplify, and that would give us, we know that 4 and 12 have a common denominator of 4, so we divide 4 by 4 and we get 1. We divide 12 by 4 and we get 3. That'll leave us with 3 to 1, and that'll give us our answer. And that is our unit rate. We simply simplified there, dividing both of these by 4. Now, and maybe an easier way for some of you is to remember that if you want to get the unit rate, all you have to do is divide the top by the bottom. So we divide 4 into 12 and we get 3. So there are 3 boys who like trucks for every 1 girl who likes trucks. And really that's kind of a way of simplifying too. So 3 to 1 is our answer. You might want to follow this one or this one, this way of doing it, if it makes it easier for you. Finally, we got one more problem down here. The same students were asked about their color preference. 27 students said they preferred red for their car. 27 said they preferred red. What percent of students preferred red? So we need to start with a ratio, right? We need to start with a ratio. We have 27 students out of how many? Well, we have a total of 50 students. So 27 out of 50 students said they preferred red. Now, let's use our proportion to solve this problem. What percent of students preferred red? Well, a percent is always a ratio of something to 100. So we know the 100 is going to be on the bottom, but we don't know our top value. Well, fortunately, this looks like every other proportion that we've solved, and we're just going to cross multiply to solve this. So we'll wind up with 50 times x, 50x, is equal to 27 times 100. That's going to be 27 with 2 zeros after it, 2700. And then we have to do our division. Now that's actually pretty easy to divide, but we'll solve our equation. 50 divided by 50, we're doing our inverse operations. 50 divided by 50 is 1. 1 times x is just x. Whatever we do to the left, we have to do to the right. So we'll pull up our trusty dusty calculator, even though, again, it's pretty easy. This is a little bit quicker for me to show you. And we'll take 2700 divided by, line division, 2700 divided by 50, and that is 54. So x is equal to 54. What percent of the students preferred red? Well, 54% did. 54% of the students preferred red.